right, great job on your homework, Kelly. Make sure you're paying attention and staying with me. Go ahead and put your homework underneath your desk and take out your books. We're going to be on page 131. But before we get there, let's go over a few questions, a few things to make sure that we have it in our brains really well. So Kelly, remind me what a monomial is.
Monomial is one algebra thing.
One algebra thing. I think you mean term. Maya, can you help her out? Is a term with just one n. Can you give me an example of one? 2x. That is a great example. Up here I have two monomials, and we are doing an operation to them. So I have 2x over 4x. Joy, what is the operation that we're doing? Division. And she knows that because we know anytime we have a division bar, that means we are dividing. Anytime we have a fraction, that means we're dividing. But there's something I want to draw your attention to, and we've been practicing dividing monomials, and we know that we just come through here and we would do like this to get a final answer of 1/2. Y'all all followed that in your head, and you had that pretty well. But what are we doing? This is a term we learned a long time ago. What are we doing when we mark out this x and this x? What do we call that, Kelly?
Cancel out.
We call it canceling. So keep that in mind. It's really not that difficult. We're just canceling. So the same way we're canceling monomials when we're dividing them, what about when we have monomials that we are multiplying? There is a term that we can use for multiplying our monomials. And what is that term, Mark? Right. It is, we could see it as a distributing because we're distributing to each one. Kelly, you're paying attention. Up here, so we are going to distribute those to each one. Great job. So we have our dividing and our multiplying of monomials down pretty well. And now we're getting to some algebra, we're getting to some terms and different things. And what kind of terms can we add together, Kelly?
Like terms.
Like terms. So can I add together x's and y's, Joy? No, all of you are shaking your heads, no. And why can't we add together an x and a y? What is that like, Maya? Right, two different scenarios. It'd be like adding desks and tables together. Well, those don't go together. We have to add desks and desks together. So make sure we're keeping those like terms. You remember several days ago, and I gave you an example of a recipe, and I said that I wanted to make a recipe, or maybe you were going to make a dessert for a party, but you didn't have quite enough for how many people that were going to come. And we said that your recipe only made for 5 people, and you had 15 people coming to your party, so you needed more things. And you needed more eggs and more flour, but how do you know how much more? Do you just make the recipe as many times until you have enough? And some of you piped up and said, well, no, you're just going to make it 3 times. And that's when I told you that you were doing algebra. And we see algebra in things that we do every day. Your mom probably uses it when she goes to the grocery store. Maybe your dad uses it. Maybe he's a carpenter or something, and he uses it when he's building, or maybe an accountant. We use algebra everywhere we go and everything we do in life. But there are some very simple steps that we're going to learn, we're going to memorize, and we're going to follow to help us know how to solve equations when we have them. So everybody look up here at the board with me, and I want you to see the first equation that we have that we're going to work on today, and it is x plus 3 equals 15 over 3. Now, we want to know what x is. So first of all, when it comes to coefficients, what kind of coefficient is x, Kelly? Do you remember?
A literal?
It is literal, so that's right. Anytime we have an equation, we are trying to get the literal equation a number. We're trying to figure out what is x. All of this time, we've been dividing monomials, multiplying them, we've been joining terms together, but I've been saying the whole time, we don't know what x is. It could be 4, it could be a million, it could be anything. But today we're going to learn how to actually get a value for what x is. And there's a few steps that we're going to use and that we're going to get in our heads, and when you're going through these, you're just going to be going over and over and over them. So the first step is to simplify. We're going to look anytime we have a problem, and we are going to want to simplify the problem. What do you think I mean by simplify, Mark? can, joining it together. That's right. So we're going to look at this problem. I'm going to look at this problem, and I want to simplify. Kelly, you don't need to be digging in your bag. Just be looking up here at the board. Okay, get your paper out. So we're going to simplify up here first. Now, I know that you all don't always like working with fractions because sometimes I don't either. And we have a fraction up here. But this is a nice one because we can just go ahead and make this a nice whole number. We know that 15 over 3 is equivalent to 5. So I can go x plus 3 is equal to 5. And I didn't change this at all. I just rewrote it in a more simple way. So the first thing we're going to do when we have an equation is what, class? Simplify. That's right. So we've simplified as much as we can here. The next thing is to identify the unknown. And our unknown up here is pretty obvious. It's the x. Because we know what 3 is. We know what 5 is. But we have no idea what x is. So we know what the unknown is. And now the next step is to get the unknown alone. Everybody say it with me. Get the unknown alone. But you might say, Ms. Jordan, how are we going to get the unknown alone? We're going to get the unknown alone by doing opposites. And you think, what do you mean we're going to do opposites? Okay, so we're going to look here, and what is keeping this x from being alone? Everybody can see it is the plus 3. It's keeping us, we want this x to be all by itself, but this 3 is in the way. So we're going to get the unknown alone by doing the opposite. And we see that this is a plus 3. And we've gone over our operations time and time again. Some of you remember I've been asking y'all a lot the past few days, what is the opposite of addition? What's the opposite of multiplication? Well, the opposite of addition is subtraction. And we know that. So we're going to subtract 3 from this side. But there's one thing you have to do. You have to always, always, always do this. Whatever you do to one side of the equation, you must do to the other side. If you don't do it to the other side, then you have completely messed up the problem and it's not going to get the right answer. So whatever we do to one side, we have to do to the other. So I'm going to rewrite our equal sign and I'm going to subtract 3. Does everybody follow why I'm subtracting 3 from both sides? That way I'm keeping it nice and balanced all the way through. So 3 minus 3, we know we're going to get 0. So if we want to put 0, we can. And 5 minus 3 is 2. So we're going to bring this down. We have x plus 0 equals 2. But we know anything plus 0 is itself. So we have x equals 2. So now we finally have a value for what x is. We know that x equals 2. Well, maybe you're thinking, well, maybe I don't think you're right. Maybe it's not x equals 2. Well, there is a great way that we can check this. And we learned this a few days ago, I think a couple lessons ago. We learned what to do when they give us what a value is and we plug it back in. What do we call that, Kelly?
You substitute it.
Substitute it. And what else did we call it, Joy? Evaluating. That's right. We learned how to evaluate at certain numbers. So it is substitution and it is evaluating. So we're going to take our 2 and we're going to come and we're going to look at the original problem. We're not looking at any of this right now. Our original problem was x plus 3 equals 15 over 3. We're going to put into anywhere we see an x. So I'm going to go 2 plus 3 equals 15 over 3. So now we're going to simplify because that's the first thing we do anytime we have a problem. So I know 2 plus 3 equals 5. And 15 over 3, we already said up here, it equals 5 as well. Well, everyone in this class, do you agree that 5 is equal to 5? You do, so we can put a check by that. I meant to bring my big green check for when we check these, but we know that our final answer is x equals 2. And we did that with just a few steps. Remember, our first step was to simplify. Our second step was to identify and get the unknown alone by doing opposites. Our third step was to, whatever we do to one side, we have to do to the other. And then you just work your problem, work your arithmetic from there. So let's go ahead and look at this problem, and it's very similar, so I want you guys to help me since we just did this one, and it's a lot like it. Help me with this one. So first things we're going to do is simplify. And class, what are you looking at? Look at this. Let's see. What can we simplify, Kelly?
20 over 2 to 10.
Okay, 20 over 2 to 10, and why is 20 over 2 equal 10?
Because half of 20 is 10.
That's right. So we're going to go ahead and rewrite this. X plus 5 is equal to 10. So we simplified. What was our next step, class? That's right, get the unknown alone. So we're going to find our unknown, and what is our unknown, Mark? It is x. That's right. So we're trying to get x by itself. We want to move everything to the other side by doing opposites. So let's go ahead and we're going to subtract this 5 because the opposite of plus 5 is minus 5. So we're going to subtract 5 from both sides. So we know this is going to be 0. I'm going to move my x down here. So 5 minus 5, class?
0.
And then 10 minus 5, class?
5.
Is 5. So we got an answer of x equals 5. But let's go ahead and check it. Let's evaluate our answer to see if we got it right. So what am I going to do to check my answer, Kelly?
I'm going to evaluate it
And how do I do that?
by putting my x, or 5, substituting into the x.
Right, so we're going to use this problem?
No.
We're going to use this one. That's right. Make sure, class, we always use our original problem that we were given. So we would have 5 plus 5 equals 20 over 2. And we know that 5 plus 5 is 10. And 20 divided by 2, class,
10.
is 10. That's right. And I almost made a mistake that sometimes you might be tempted to make. I almost circled that 10 equals 10 is my answer. But is that my answer? It's not. What is my answer, Joy? X equals 5. So make sure you circle your final answer so it doesn't get lost in everything that we have here. Go ahead and look at practice problems on page 131, and we're going to do number 1. I want you to do number 1 at your desk. Once you're done, you can look up this way. Just a few more working. All right, looks like everybody has finished up. And remember, we had that checklist of things to go through, and I actually brought my checklist today on a little chart, and I'm going to put it over here so we can refer to it whenever we need to. So we have our checklist, and we want to go through each part of the checklist to make sure that we have it right. So Kelly, what is the first thing on our checklist?
Simplify each side.
To simplify each side. Mark, what do we need to do? What did you do to simplify each side? It was already simplified for us. There was not a whole lot to do here. 12, not much we can do with that. So Joy, what is our next step? To get the unknown alone by doing opposites. And what did you find the unknown alone to be, Joy? X. Yep, so we're looking for X. Most of the time it is going to be X, but you never know. They might give us A or B or C, something like that. So up here in our problem, it is X. So now we have the unknown, but how are we going to get it alone, Maya? What can we do? Opposites. So you said we want to add 3 to both sides. So now that we have our add 3, we're just going to move through, and Maya made sure to note that we do it to both sides. Remember, whatever you do to one side, class, what do you have to do to the other? The same thing. So we have to keep doing the same thing. So now we know that these will cancel, and that will leave us with X equals, what did you get for 12 plus 3, Aloha? 15. Is that what everyone got? 15? So X equals 15. So now we're going to check this. We always check our work. We always want to make sure that our answers are right. It's one thing when we can have a problem and we're not sure how to check it, but if you can check it, you always want to be sure to check it so you know that you're going to get full points for it. So how are we going to check this, Mark? Right, we're going to plug it back in. So we're going to go 15 minus 3 equals 12. Well, we know 15 minus 3, class, 12. That's right, 12 equals 12. Make sure everyone is participating on our class questions. So 12 equals 12. We got that right, and our final answer is x equals 15. Great job on that one. I hope you all got the same answer that we had. So far, we have looked at problems. We've looked at getting the unknown alone, but the only way we've been getting the unknown alone is just adding or subtracting a number that we had and moving it to the other side. So what happens when we have a monomial with more than just one literal coefficient? What if we have a monomial that has a numerical coefficient in it? What are we going to do? Go ahead and turn your attention over here to the sideboard. So the first thing we're going to do is simplify. I love to simplify because it makes our lives so much easier. So we're going to go ahead and simplify this as much as we can. So make sure you are following along with me or doing this on your paper. We have 16 minus 7. I can go ahead and simplify that because we know 16 minus 7 is equal to 9. Well, now I need to identify my unknown. What is the unknown, Kelly?
The unknown is the 5x.
Is the 5x. Okay, so we're going to run into a problem here, but we're going to get as much of it unknown as we can to start out. So you already know the drill. We're going to subtract 4 from just one side, Kelly, right? I'm just going to subtract 4 from right there.
No,
She
but-
says no. I see Maya shaking her head no. Why not, Kelly?
Because what you do to one side, you have to do to the same.
We have to do to the other. That's right. Make sure you catch that. So we have 5x and 9 minus 4 is 5. Okay, so now we're kind of in a predicament. We can't just add 5 because we can't subtract a 5. We said we get the unknown alone by doing opposites. So what operation is being done right here, class?
Multiplication.
We know that that is multiplication. Anytime we have a number and a letter together and there's nothing between them, we know that we are multiplying. So we have multiplication, and the opposite of multiplication is division. We've gone over that with our monomials and our multiplying and dividing. So we know with our multiplication, the opposite is to divide. So I'm going to divide 5. Because if I divide this 5, then it's just going to cancel like that. But I'm forgetting one thing. What am I forgetting, Maya? I have to do it to both sides. So I'm going to divide 5 over here as well. So these will cancel, and that will give me, what is 5 divided by 1, class? 5 divided by 5, class. I gave you the answer. It is 1. So we got 1 as our answer. X equals 1. Well, let's see if I did it right. I'm going to do it over here. So I'm going to take my 1 because I'm checking, and I'm going to plug it in wherever I see an X. So we're going to go 5 times 1 plus 4 is equal to 16 minus 7. Okay, so we know that 5 times 1, class, is 5 plus 4 is equal to 16 minus 7. And this is easy arithmetic. You all have this. We know that 9 is equal to 9, and I think that checks to be right. So our final answer is x equals 1. So we have a similar problem over here. It's a little bit different in that we have a couple of terms that are scattered. So first of all, we have to simplify. And how can we simplify this, Mark? Okay, you want to add 4x and 2x together. And why can we add those together, Joy? Because they're like terms. If I had 4x and 2y, well, we can join those together because they're not the same. But since these are the same, we can go ahead and join those together to give us 6x equals 18. This side was already good by itself. Okay, so now we have identified the unknown. Our unknown is x. And we see that we are multiplying here. So what is the opposite of multiplication, Kelly?
Division.
It is division, so we're going to divide by 6 to both sides. Make sure we do it to both sides to give us x equals 3, because 18 divided by 6 is 3. So let's go ahead and check that. This is going to be a little bit longer one. So we're going to have 4 times 3 plus 2 times 3 is equal to 18. All right, class, help me out with my arithmetic. What is 4 times 3, class?
12.
12 plus 2 times 3, class,
6.
is equal to 18. Oh, that was a terrible 8. So 12 plus 6, Joy, is 18. So we have 18 equals 18. So we know that our final answer, that is correct. Yes, Kelly?
Can I have my notes, please?
Yes, you may. So go ahead and look on that same page. It's going to be 132 now, and do number 11. Make sure you're following that check sheet of things to do. Kelly, you may step out if you need to. You may step out in the hallway. Have a seat at your desk. That is not how we throw our things away. Kelly, you can see me after class.
Sam.
All right, everybody should be just about done with number 11. I'm getting it written here up here on the board so we can work it together. I messed it up just a little bit. It is 14 plus 4 equals x plus 5x. All right, it looks like everybody is finished. Kelly is finishing that one up. So, Jobin, what is the first thing that we want to do? We want to simplify, that's right. So we're going to simplify, and what did you do to simplify first, Joy? Okay, you did 14 and 4 together to get 18. And Maya, did you stop right there, or did you have something else to simplify? You did. So you did x plus 5x, and we can do that because they're like terms. That would give us 6x. So now we need to identify the unknown. Now there's one thing I want us to look at, but we have identified the unknown, and it is x. It is 6x. Kelly, make sure your eyes are up here. Could I write this problem like this? Could I rearrange this? And is that the same thing, Kelly? Is this the same thing as that?
Yeah.
It is, and why can't we rewrite it that way if we chose to?
Because you're essentially doing the same thing.
Right, because the equal sign, it's not a sign of operation, it's just telling, so as long as we keep all of the signs, we can flip them. So we have 6x equals 18, and you might be more comfortable working it from this side, because that's how we've been practicing it. So we can swap them as long as we keep all of the same things on each side. So let's go ahead, we have our unknown, and we want to get it unknown by doing opposites, and what's the opposite up here, Joy? That's right, it is division. So you divided by 6 to both sides. So that would have given us x equals 18 divided by 6, class.
3.
Everybody should have gotten 3. That's what I got on my paper. We'll put it in to check it out. So let's go 14 plus 4 is equal to 3 plus 5 times 3. 14 plus 4, Jobin. Okay, you had 18. And Mark, what did you get for this? So you had 3 plus 15. And Joy, 3 plus 15 is 18. That's right. So we had 18 equals 18. Looks like it matches to me. So your final answer is 3 equals x, or x equals 3. Now we have one last type of equation that we want to look at before we delve into doing all of these and putting them together. So everybody look with me at this one. 3/5 x is equal to 9. So So we know in our checklist that the first thing we want to do is simplify. What can be simplified up here, Kelly?
I don't see anything.
You don't see anything. Maya, do you see anything? I see all of you shaking your heads. We've already this is already simplified. There's not a whole lot more that we can do. But we still have this old fraction. Those fractions that we just want to get rid of as fast as we can. Well, we want to get rid of it because we know that our x is what we're trying to get by itself. So in this situation, we have to do 2 times the opposite thing, okay? So the first thing we have that is blatant is our division. So what is the opposite of division, Joy? Multiplication. So now we're going to multiply both sides by 5. So I'm going to multiply this whole thing by 5, and I'm going to multiply this over here by 5. Okay, so now we can see that these are going to cancel to give us just 3x. And I did it to both sides, and 9 times 5 equals, Kelly? 45. So we know we can just divide. That is one that we have seen before. So x, oh, I forgot to show that we need to divide. So we're going to divide by 3 on both sides. So x equals 15 because 45 divided by 3 equals 15. So we're going to go ahead and check that. So we're going to go, I'm just going to do it right here. 3/5 times 15 is equal to 9. Well, 5 will cancel out. Does everybody agree with what I'm doing there? Okay, so that will give me 3, and we know that 3 times 3 is 9. So it checks out. X is equal to 15. Go ahead and look at your practice problems. They're on page 132. I would like you to work on 2, 3, 4, and 5. 2 through 5 at your desk. Mark, make sure you're working on your work. If I can get Kelly to do 4 at the board, and Jenna, you come do number 5 at the board. Kelly number 4 and Jenna number 5. The rest of you make sure you're working diligently at your desk. Don't forget in those instructions, I see some of y'all leaving it off, it does say to check your answer. So go ahead and check your answer. To verify that you got it right. You can have a seat once you're done and go ahead and finish those. You're working on 2 through 5. Most of you look like you're about to finish up. Kelly, make sure you're working on your work. You'll be seeing me after class. Okay, if you had work at the board, go ahead and make your way to the board so you can show it. We're going to go over these. So you were doing 2 through 5. Number 2, Jobin, what did you get for number 2? You got y equals 19, and he is correct. If you plugged it in, you would have seen that he was correct. Great job. And then number 3, Maya, you had m equals 3. Great job. I think the whole class agrees. All right, very nicely done. Kelly had number 4. Go ahead and show us what and why you did what you did.
So I added these because they are like terms. So I have 3x equals 15. I divided by 3, got x equals 5. I went and checked my work, got 15 equals 15.
Does everyone agree? I think so. That's exactly how I would have done it, Kelly. Great job. You can erase that and have a seat. And then Jenna with number 5, our last one, show us what you did.
So I had 1/2 y equals 3, so I multiplied both sides by the reciprocal of 1/2 so I could get y by itself. And so then the 1/2 canceled out with being 2, and 3 times 2 equals 6, and then I collected it in my calculator.
She did a great job. Leave that up here just for a second. Thank you, Jenna. The whole class agrees with Jenna. And she used a word that I want to draw your attention to. She called this the reciprocal, and that is, she is correct, and that's one that we have talked about before. This is the reciprocal. 1/2 would be 2/1, and that way she knew that both of these canceled, right, Jenna? That's how you knew. Great job. You all can put your books away and take out your homework notebooks. Your homework for tonight is going to be sharpening skills 2 through 24 even on page 133, 2 through 24 even, page 123. You all, great job listening today. You're dismissed.